ON Semiconductor is a chip maker that specializes in power management chips using silicon carbide, a material that can handle higher voltages and temperatures than conventional silicon. These chips are in high demand for electric vehicles, as they help improve the efficiency and performance of the powertrain, battery, and charging systems. The company has been supplying its power management chips to some of the leading automakers and Tier 1 manufacturers in the world, such as Tesla, Volkswagen, Toyota, Hyundai, SIC, and Bosch. These customers have ambitious plans to increase their EV sales in the coming years, which will boost the demand for ON Semiconductor's products. According to the company's analyst presentation, the automotive market is a growth market for ON Semiconductor, mainly due to the rise of EVs. From 2022 to 2027, electric vehicle sales are expected to grow at a compound annual growth rate, CAGR, of 18%, while hybrid electric vehicle sales are expected to grow at a CAGR of 12%. These are positive developments for ON Semiconductor, as its power discrete products for EV have higher content and margins than those for traditional combustion vehicles. The company has also invested heavily in expanding its production capacity and capabilities for silicon carbide chips. In May 2023, the company announced that it was considering investing $2 billion in boosting production of silicon carbide chips that are widely used to help extend the range of electric vehicles. The company is weighing the expansion in either the United States, the Czech Republic, or Korea. In addition, the company has acquired GT Advanced Technologies (GTAT) in February 2022, a leading provider of silicon carbide materials. This acquisition will enable ON Semiconductor to secure its supply of high-quality silicon carbide wafers and reduce its dependence on external suppliers. The company expects to achieve significant cost savings and synergies from this acquisition in the long term. By specializing in power management chips using silicon carbide and supplying them to the booming EV market, ON Semiconductor has boosted its growth and margin targets. The company expects to grow its revenue at a CAGR of 10% from 2021 to 2026, while improving its gross margin from 36% in 2021 to 42% in 2026. The company also expects to increase its free cash flow margin from 13% in 2021 to 20% in 2026. ON Semiconductor is a chip maker that has become the master of the EV market by leveraging its expertise in silicon carbide technology and its relationships with key automaker customers. The company is well positioned to benefit from the electrification of vehicles and the increasing demand for power management chips that can handle higher voltages and temperatures. The company has also invested strategically in expanding its production capacity and capabilities for silicon carbide chips, as well as acquiring a leading provider of silicon carbide materials. These moves will enable ON Semiconductor to secure its supply chain, reduce its costs, and improve its margins. ON Semiconductor is a chip maker that is powering the future of mobility with its innovative and high-performance products. One of the key factors that makes electric vehicles, EVs, more efficient and reliable than traditional combustion engines is the use of silicon carbide, SiC, chips in their power electronics. SiC chips are semiconductors that can handle high voltages and temperatures better than conventional silicon chips, making them ideal for EV applications. Silicon carbide is a compound of silicon and carbon that forms a variety of crystalline structures with different electrical properties. Unlike silicon, which has a bandgap of 1 to 1.5 eV, SiC has a bandgap of 2.3 to 3.3 eV, depending on the structure. The bandgap is the difference in energy between the valence band and the conduction band of a material, and it determines how easily electrons can move from one band to the other when an electric field is applied. A higher bandgap means that SiC can withstand higher electric fields than silicon without breaking down or losing efficiency. Silicon has a breakdown voltage of around 600 V, while SiC can tolerate voltages 5 to 10 times higher. This allows SiC chips to operate at higher voltages and frequencies, reducing the size and weight of the power converters and inverters that are essential for EVs. Another advantage of SiC chips is their higher thermal conductivity, which relates to how fast they can get rid of the heat that they generate during operation. SiC has a thermal conductivity of about 3.7 W/cmK, compared to silicon's 1.5 W/cmK. This means that SiC chips can operate at higher temperatures without overheating or requiring additional cooling systems, which also saves space and energy. Moreover, SiC chips have higher electron mobility than silicon chips, which means that they can switch on and off faster and more efficiently. SiC chips can switch at nearly 10 times the rate of silicon chips, resulting in smaller control circuitry and lower switching losses. This improves the overall performance and reliability of the power electronics in EVs. In summary, silicon carbide chips are more power efficient and can handle high voltages and temperatures better than traditional silicon chips, making them ideal for EVs. By using SiC chips in their power electronics, EVs can achieve higher efficiency, longer range, faster charging, lower emissions, and lower system costs than conventional vehicles. Wolfspeed is a power chip maker that specializes in silicon carbide, a material that can handle high voltages and is more power efficient than traditional silicon. Silicon carbide power chips are in high demand for electric vehicles, as they can improve performance, range, and charge time. Wolfspeed claims to produce more than 60% of the world's silicon carbide and has a multi-year agreement with Lucid Motors, an emerging leader in electric vehicles, to supply its silicon carbide devices for the award-winning Lucid Air car. To meet the surging demand for EV power chips, Wolfspeed is building a new multi-billion-dollar factory in Chatham County, North Carolina, which will be the largest silicon carbide materials facility in the world. The factory will produce silicon carbide wafers that will be used mainly for Wolfspeed's own chip manufacturing needs. The factory will also enable a 13 times increase in Wolfspeed's silicon carbide wafer making capacity. The first phase of the factory is expected to be completed by 2024, with a total investment of up to $5 billion. Wolfspeed is also planning to build another large fabrication facility in Germany, pending subsidy approval from the European Union. Wolfspeed's expansion plans reflect its ambition to be the global leader in silicon carbide technology and to support the transition to an all-electric future for transportation.